You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620 26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its 2 host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star. Not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand. others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing toward the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. But several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ringed planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. Two of them, Pandora and Prometheus, flank the F-ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But two of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. But they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, we'll have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So, maybe we take that effort and save us from a real threat, climate change. Just saying.
Hey, look up! There's a meteor shower happening right now! Okay, not really. But I made you look. If you're a fan of full moons, there's one coming up very soon. On February 27th to be exact. I really hope this video comes out in time. The moon will be lit up right in front of our eyes because it will be located on the opposite side of the Earth, where the sun is. It will help illuminate the moon, providing us with a night to remember. Take a good look at it. Doesn't it sort of resemble a huge snowball just hanging from the sky? Some native tribes in the northern hemisphere of our planet might have thought the same. That's why they used to call it the snow moon. You know, when it was big and full, like this. Okay, go ahead and grab a telescope now, because on the 9th and 10th of March, there are 3 planets that will line up for your aesthetical pleasure. Starting from top to bottom, you'll see Jupiter, then Saturn, and last but surely not least, Mercury. Now, depending on how good your telescope is, and if you've even got one, chances are you'll see some details of these 3 planets. You adjust your telescope a bit, and there it is, another planet. Almost like they're not thousands and thousands of miles away from each other. But that's not all. they'll be visible to the unaided eye too. This means you won't even need a telescope. Well, you'll probably see them like this, 3 bright white balls in the sky. Still astonishing though. You'll need to be looking at the southeast around half an hour before the sun rises, and voila, there they are. In the mood for a relaxing shower? How about a meteor shower instead? This time, you can keep your telescope safely stored, and you don't need to worry if you miss 1 or 2 of these showers, as there are quite a few happening this year. They're pretty evenly spread out too, and I don't mean the meteors. Those come close together. Grab your calendar and put a reminder on these months. You can choose from April, August, October, November, and December. Some months even have 2 showers instead of only 1, like October and November. Choose the month and day that works for you. Just check your calendar again. If you don't mind it being a bit chilly, just wrap yourself up in a blanket and hop in the back of your pickup truck. Then, all you have to do is stare up and enjoy the sky all night long, waiting for the shower to happen. Or, if you like to work by the clock, set up an alarm to wake you up in the middle of the night. That works too. Mercury's coming right at you! Watch out! Nah, don't fret. It's still right up there, just a bit closer than usual. That's because on the 17th of May, it'll be at its greatest eastern elongation. What this means is it will be easier to observe. Right after sunset, point your eyes to the skies in the west and try to look for the planet. This happens again during the 4th of July, but this time you'll have to look to the east. You might need a compass. Start your celebrations early in the morning, just before the sun rises, with a gorgeous view of Mercury, and of course a cup of coffee in your hand. If you still don't catch it then, try September 14th or October 25th. How about when the moon loses its natural white color? This happens just a few days after Mercury's first performance, on May 26th. It's called a total lunar eclipse. The moon will get gradually darker, as if someone was dropping dark red paint on it, until it finally reaches this sort of rusty red color that you can see on the screen. Not all of us will be able to see this unless you're on a cruise in the Pacific Ocean or in the calm fields of Eastern Asia. If you live next to the Tokyo Tower, you're in luck. It'll be visible throughout the whole of Japan. And if you happen to live in the western part of North America, you'll also be able to see the moon shapeshift. Well, not quite shapeshift. It's not going to turn into a wolf or anything. That only happens if you're a werewolf, which I definitely am not. So it's more like a color shift. Still, on the moon, picture a massive black hole. Well, this next astronomical event kind of resembles that. On June 10th, during the annular solar eclipse, the moon will be the furthest it ever gets from Earth. While it's doing this, it ends up covering most of the sun, leaving just a bit of its curvature for us to see. If you happen to look at the sky during this time, what you'll see is a massive ring of light. Chances are you won't be able to tell that's the moon out there, since it'll be the same color as deep space, the absence of color, or just a very deep black. Oh, and that ring you're seeing? That's the sunlight. Okay, since we're talking about rings, I've got one for you, Saturn's ring. This planet is the full package. It's a planet, it has a ring, and get ready for this, it has 82 moons. It feels like every year a few new ones pop up out of nowhere. Anyway, during August 2nd, the planet will be at its closest point to Earth, and the sun will help us catch a good sight of it by brightly illuminating it. Not only will it be brighter than it ever is during the whole year, but it will also be visible all night long. This is the time to get that telescope ready again. A medium-sized one should do the trick. That is, if you want to see its rings and some of its moons, the ones that shine the brightest. Another planet that's coming closer is Jupiter, this time on August 19th. The same thing that happened to Saturn will happen to it. The sun will shine bright on its big planet face. The only difference is that this time, if you have a good pair of binoculars lying around, you'll be able to see the planet's 4 largest moons. Although they'll look like tiny dots, but now you know what they really are. Okay, so you've been thinking about those meteor showers I mentioned earlier. Well, this one is the best there is. It's called the Perseids meteor shower. and it almost looks like the sky is a pitching machine, except it's pitching meteors. During this particular shower, you might even be able to observe up to 60 meteors per hour. They're very bright too. Look at them go! Zoom! There goes another one. The best days to get cozy, sit on the grass, and just lie there looking at the sky is during August 12th and 13th. Usually, when these 2 days come around, the sky's dark and clear, perfect for a meteor shower. Picture a slightly red moon. That's called the partial lunar eclipse, and it happens during the 19th of November. This same red moon will get darker and darker as it moves through Earth's shadow. It won't be visible to everyone though. Here's a globe. Let's mark the places where you can see this partial lunar eclipse. First, we got Eastern Eurasia, then Japan. The Pacific Ocean's included in this list too, but unless you got a boat, you're likely not going to be there. Then we've got North America, Mexico, Central America, and lastly, some parts of Western South Africa. Grab a hold of your eclipse glasses and get ready for this last one. It's the last solar eclipse of the year. This one in particular is the best one to catch, as the moon will block the sun for almost 2 minutes. You'll be able to see the almost ghost-like sun's corona, also known as its outer atmosphere. The sad part is, you'll have to be in Antarctica or the South Atlantic. Just be careful out there. I heard it gets a little chilly.
So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dim. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have 2 axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune's size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a Next Generation Transit Survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: technosignatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbons (CFCs), can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now, let's get back to Super Saturn. The star that Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So it's not an exceptional star, just another telescopic star out there in the Scorpius-Centaur region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at 0 inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings blocked most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at 0 inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined, 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon. Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation: phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus,
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
it was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contained phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the Moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the Moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
Imagine leaving your house one morning and seeing not one, but two stars shining in the sky. The first one is our good old sun, and the other is Jupiter. But how has a planet turned into a star? And what will now happen to Earth and its inhabitants? Before we find the answer to these urgent questions, we need to revise some things we know about Jupiter. The largest planet in the solar system is a gas giant, which means it's made up mostly of gases. Due to the pressure and temperature differences, these gases separate into layers. This creates those red and white bands that can be clearly seen from Earth. The temperatures at the top of Jupiter's atmosphere are insane. They can reach a whopping 1,340 degrees Fahrenheit. The planet also has an immense gravitational pull. In 1995, the Galileo probe reached the atmosphere of Jupiter and sliced it at a speed of 106,000 miles per hour. It survived the scorching temperatures and started its descent. It kept moving even when the temperature suddenly dropped and the pressure, as well as the speed of the wind, increased. But 58 minutes and 97 miles into its exploration, things went downhill. The pressure of 23 atmospheres and still high temperatures finished the probe off. It was melted and then vaporized by the extreme heat. Now, if Jupiter suddenly decided to keep growing, it would eventually become a star, and its composition would allow this planet to do it. Once, a long time ago, Jupiter took most of the mass that was left after the formation of our Sun. That's how it ended up with more than twice the combined material of all other bodies in the solar system. And the planet's ingredients are the same as those of a star, mostly hydrogen and helium. Jupiter is just not massive enough to ignite. But what if it was? Then it would turn into another kind of celestial body, most likely a brown dwarf. In this case, it would have a minor effect on the orbits of the planets of our solar system, because brown dwarfs are more massive than planets, but not as massive as stars. A brown dwarf is usually 13 to 80 times the mass of Jupiter. It can only become a star if the pressure in its core gets high enough to start nuclear fusion. So let's imagine that it's happened, and Jupiter has become a real star. For example, a red dwarf. Red dwarfs are stars with masses around 7.5% to 50% of the mass of our Sun. Red dwarfs are also hotter than brown dwarfs. Their temperature can reach 6,380 degrees Fahrenheit. Our Sun, by comparison, has a temperature of almost 10,000 degrees Fahrenheit. So, it means that the newly formed red dwarf will be far dimmer than the Sun. And still, red dwarf Jupiter could prevent the inner planets from following their orbits, because they wouldn't be able to find a balance between the gravitational forces of the two stars. The planets would move either closer to the Sun or closer to the newly formed red dwarf. If Earth chose the first option, our main star's insane temperatures would probably wipe all living beings off the face of the Earth in no time. If it was the second scenario, we'd probably freeze, since Jupiter, as a dim red dwarf, wouldn't be able to warm us up well enough. But there could be one more option. The inner planets could get thrown out of the solar system altogether. If Jupiter was a star, it would also greatly increase the amount of radiation the surface of Earth would receive. Our atmosphere would have to protect us both from the radiation coming from the Sun and from Jupiter's radiation. Red dwarfs are notoriously active. That's why Jupiter, just like the Sun, would most likely have frequent coronal mass ejections. This is a fancy expression for describing large clouds of electrically charged particles a star releases with a huge burst of speed. Even now, Jupiter has a significant impact on our planet. The gas giant is roughly 318 times as massive as Earth. And this also means it has an outsized pull on our planet. Its gravity can cause shifts in the orbit of our planet and climate swings every 400,000 years or so. When Jupiter's influence is the strongest, Earth usually has colder winters, hotter summers, and more intense periods of wetness and droughts. Also, if Jupiter turned into a red dwarf, its most prominent feature might probably disappear for good. I'm talking about the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the tops of the surrounding clouds. The storm is almost twice as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are negative 280 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. They were higher than the temperature of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear altogether. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. And now, I have another what-if situation for you. What if Jupiter collided with the smallest star we know about? Today, these two space bodies are on a collision course. A spoiler, Earth might not survive such an encounter. Okay, meet this tiny red dwarf. It's the size of Saturn, and its gravity is around 300 times the gravity of our planet. It normally floats 600 light-years away from Earth in a double star system. But today, for some inexplicable reason, it's broken all the laws of the universe and is rushing toward the biggest gas giant in our solar system. And even though this space guest is smaller than Jupiter, its mass is way greater, and its gravitational force soon starts to pull on the gas giant. The heat from the red dwarf, plus its powerful gravity, makes Jupiter grow in size. The planet's atmosphere starts to puff up because the gases that make up the planet begin to heat up and expand. Jupiter's atmosphere starts to leak into space toward the stellar visitor. Sometime later, the runaway gases form a bright hot ring around the red dwarf. This is a terrifying view, as if a black hole, a very bright one, has appeared inside the solar system. The star keeps tearing Jupiter apart, eating chunks of the gas giant, and soon the red dwarf engulfs it completely. Sadly, Jupiter never stood a chance. Instead of the gas giant, we now have a red dwarf surrounded by a ring of hot gases. And we already know how badly it may end. The best thing about it is that this scenario is totally imaginary. Phew, thank goodness.
Now in space, inky darkness between blinding points of light does a great job. It hides black holes, gaping, hungry, and scary. Their blackness makes it really difficult for astronomers to find detailed information about these space monsters. When a powerful and massive star reaches the end of its life, it can't just fade into nothingness. One of the most likely scenarios, the star will run out of its nuclear fuel. Then, in a blazing flash of light, it'll collapse under its own gravity. If the star was large enough, it'll turn into a black hole. There's a hypothetical type of black hole called primordial. Scientists have never gotten any real proof of their existence. These holes are insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes have most likely evaporated away, but the bigger ones can still be scattered out there in space. But how did primordial black holes appear in the first place? In the very beginning, space wasn't the same. In some regions, it was hotter, in others, cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though? These holes might be so small exactly because they popped up right after the Big Bang. The longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our Sun's and that of a jelly bean. Now you get it. There was a theory that primordial black holes could actually be dark matter. This matter is believed to make up around 80% of the mass of the observable universe. Astronomers can't see this bizarre ingredient directly, since it doesn't emit light or any kind of energy. The idea remained unpopular for decades, but recently, scientists have realized there are many more black holes in the universe than they used to think, and it means the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching. Some scientists argue that dark matter can't be tons of multi-sized primordial black holes. They would collide far too often for this to work out. Others object that black holes might exist in twos, and then a third one can always approach the pair and replace one of the initial holes. After all, our universe is swarming with black holes, and there's no lack of them. This process would repeat again and again, meaning there would be almost no merges or collisions. Primordial black holes might stay in clusters the size of the distance between our Sun and the nearest star. Each of these clusters can be home to thousands of black holes, all crammed together. A 30 solar mass monster of a black hole might sit at the center, with more common stellar ones occupying the rest of the space. Such clusters can be everywhere astronomers think dark matter is. But so far, this is still only an exciting theory, and some scientists don't support it yet. More data is needed. Now, black holes sometimes behave like massive galactic volcanoes. From time to time, they flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Whoa. Recently, astronomers have found out that one of the most massive stars in the neighborhood might just have vanished. The star used to hover in space 75 million light-years away from Earth. It's usually too far away for scientists to clearly see individual stars, unless they're really massive, like the one we're talking about. It was gigantic and shining 2.5 million times brighter than our Sun. For the last time, astronomers saw the star's light in 2011. But when they decided to examine it more closely several years later, they couldn't find it. Such huge stars usually go out in an extremely bright supernova. But nothing here, which puzzled the scientists to no end. There's a theory it collapsed into a black hole, and it happened without triggering a supernova first. It does occur among stars nearing the end of their lives, but very, very rarely. KB 141b is a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate into clouds, condense, and get back to the surface as rain. But instead of water, this all happens with rock. The surface of the exoplanet is covered with lava seas tens of miles deep. The temperature on K2-141b reaches 5,000 degrees during the day. That's hot enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor to the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Well, looks like we're gonna need a bigger bumbershoot. A star in the galaxy GSN 069 might turn into a planet the size of Jupiter in the next trillion years or so, all thanks to the star's regular encounters with a black hole. First, astronomers noticed bizarre X-ray bursts. Those were super bright and went off every 9 hours. After examining this phenomenon, the researchers realized it was a star getting flung in a unique orbit around a black hole, and the flashes they saw were the material being slurped off the star's surface. It happened every time the star darted past its greedy host. Over millions of years, the black hole has already transformed the red giant into a white dwarf, and the process isn't going to stop anytime soon. Astronomers have recently discovered some traces of phosphine in Venus's atmosphere. On Earth, this colorless and flammable gas is often found near microbes. That's why a new theory claims there might be life on Venus. But if there is, it could only appear high in the clouds, because no living organism would be able to survive the planet's extreme environment. Its surface is incredibly dry, with no liquid water, and the pressure 90 times greater than that on Earth's surface. The temperatures there reach almost 900 degrees, hot enough to melt certain metals. So that's a no? Methane, a gas that's usually produced by living things, was found on Mars in 2013. European Space Agency's Mars Express spacecraft detected it in Gale Crater near the Martian equator. This discovery might one day answer the question if there's life on Mars. Asteroid 2019 OK scared scientists by sneaking up on our planet in July of 2019. This rather large rock, up to 400 feet across, appeared seemingly out of nowhere. It traveled uncomfortably close to the Earth, a mere 45,000 miles away. That's less than 1/5 of the distance to the Moon. The Sun's outer layer is way hotter than its surface. The temperatures vary from 10,000 degrees close to the surface and a mind-boggling 1 million degrees in the corona. That's the Sun's outermost layer. The reason for this phenomenon might be nanoflares. Those are regular, powerful bursts of heat from the star. Another theory blames the layer that lies just beneath the Sun's surface. It seems to generate a weak magnetic field. That's why, when the energy from this layer leaves the Sun, it heats the corona through a mesh of magnetic branches and roots. The Moon might still be shrinking. Our planet's natural satellite has become 150 feet skinnier than it used to be several hundred million years ago. If its insides keep cooling, it might explain the quakes shaking the Moon's surface. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Mars quake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Mars quakes have been detected. Those are the first quakes on any space body other than the Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses are. Maybe after midnight they're gonna let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Oh, by the way, our moon also has some sort of atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. Or, really thin.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the Sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the Sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time, from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us. A powerful burst of gamma radiation lasted a mere half second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Astronomers examined the phenomenon with X-ray, radio, optical, and infrared waves. It turned out that people had finally seen a newborn magnetar for the first time ever. It was likely formed after 2 neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22nd, 2020. Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of its nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. If not, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our sun is almost 865,000 miles across, which is 109 Earths put side by side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. It's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When 2 neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's a rare form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. Even your molecules would change under the influence of the star's field. In the end, you'd pretty much vanish. If a magnetar flew within 100,000 miles from our planet, it would wipe out all the data on every single credit card in the world.
Jupiter's gravity shattered a huge comet. It wasn't enough for the space monster. A real catastrophe happened. The shards didn't fly in different directions. They lined up and rushed towards Jupiter like the rail cars of a train. 21 fragments up to 1 mile in diameter burst through Jupiter's atmosphere. Fireballs at the speed of 37 miles per second bombarded the planet's shell. They heated the space around them to 50,000 degrees Fahrenheit. That's higher than the temperature in the sun's upper atmosphere and 312 times hotter than you need to boil an egg. Well, I'm not hungry anymore. The impact was like from a rock falling into a pond. The meteorite fragments formed giant plumes on the surface of Jupiter. Substances from its lower atmosphere rushed upwards. The process generated a tremendous amount of energy. Overheated streams of fire shot into the stratosphere. The monsters left behind them glowing plumes 1,900 miles long. That's greater than the distance between New York and Texas. Dark bruises appeared at the side of the blows. They were about the size of the Earth. Comet Shoemaker-Levy 9 was the name of the violator of Jupiter's boundaries. The collision of celestial bodies happened in July 1994. It was a scientific sensation. For the first time in human history, a catastrophe of this magnitude was observed. The attack raised an important question for astronomers. Why is Jupiter unlucky? Space monsters attack it thousands of times more often than the Earth or any other planet in the solar system. All right, let's see. You decide to board a starship and travel to the mysterious Jupiter. A space probe would need 2 years to get there, but your starship is faster. You'll be there in... Great, the journey only took a second. Jupiter is actually big. It could fit 1,300 Earth-sized planets in it. It looks beautiful thanks to gas clouds. This planet has no solid surface, but there's a strange stain on its surface. It looks like a huge eye that can fit 3.5 Earths. This storm will scare anyone. It's 10 times higher than Everest, and the wind rushes at a speed of 300 miles per hour. It's been going on for 350 years. You wouldn't hide from such a storm in a car, so it's good you're in the starship. If all the planets of the solar system merged into one superplanet, the new object would still be 2.5 times smaller than Jupiter. Large size also affects gravity. Spacecraft use Jupiter as a springboard to jump. The giant's gravity increases their flight speed and helps them reach their target faster. Gravity has turned the planet into a magnet for comets, asteroids, and dangerous space debris. Jupiter is a true space superhero. Its gravity shield takes a hit and deflects space monsters that fly into the inner solar system. The dinosaurs don't agree, but more on that a little bit later. What if Jupiter was swallowed up by a giant vacuum cleaner tomorrow? I can only say one thing: we'd have huge problems. Without a giant shield, thousands of comets and asteroids are attacking the planet much more often. Most of them burn up in the atmosphere or aren't large enough to affect us. But there are also larger comets and asteroids. After their collision with the Earth, you can say goodbye to all life on the planet. For example, in 2009, a celestial body crashed into Jupiter. It left a bruise the size of the Pacific Ocean. It's scary to think what traces it would leave on our planet. Most likely, the Earth would turn into a fireball. But recent research from astronomers suggests that Jupiter isn't such a nice guy. On the contrary, it's a bad guy with a slingshot that shoots comets at the Earth. A physicist used computer simulations. He found that Jupiter is equally likely to deflect and send comets toward the Earth. The giant attracts potentially dangerous objects and only partially protects us. It's already tried to knock out our planet many times. 66 million years ago, a cosmic body 10 miles in size crashed into the Earth. The energy of the impact set the surface of the planet on fire. It caused a huge earthquake and tsunami. A fiery rain fell from the sky on the Earth. There were millions of tons of debris and dust in the atmosphere. They stopped the sun's rays from reaching the planet. The nuclear winter began. This disaster led to the extinction of the dinosaurs. Scientists have named this space criminal Chicxulub Impactor. Computer simulations of scientists at Harvard University showed where it came from. Chicxulub wasn't an asteroid, but a comet. This means that the core of its body wasn't stone and metal, but ice, dust, and frozen gas. It resembled a dirty snowball flying through space. The meteorite wasn't going to set fire to the Earth, but Jupiter intervened in the plan. It threw comets in our direction. In 1770, Lexell's comet appeared near the Earth. Our planet and this object were separated by only 1.4 million miles, close to nothing in space terms. Lexell's comet came closer to Earth than any other comet in human history. The object could have stopped life on Earth. The comet flew too close to Jupiter. The giant caught it and sent it in our direction. Now, this isn't a very good move for a superhero that protects the solar system. After 3 years, the comet went past us. It flew 2 times around the Sun and returned to Jupiter like a boomerang. This time, the giant pushed the comet out of the solar system. But let's not blame Jupiter. Scientists believe that without this gas giant, life on Earth would most likely never have happened. Jupiter sent meteorites toward Earth, which carried organic molecules and water with them. They were the building blocks from which earthly life began. Nobody knows if comets would come with a valuable cargo without Jupiter and its dangerous gravity. If you fly away from Earth to the center of the solar system, you'll see the Sun. 8 planets are flying around this star. There's a belt of more than 1 million asteroids between Mars and Jupiter. One theory says there was only the Sun at the very beginning of the solar system's existence. Clouds of stone and dust surrounded the star. These particles attracted each other and formed planets over millions of years. Jupiter didn't want any new neighbors. Its powerful gravity prevented rocks and dust from uniting into planets. They remained asteroids and gathered in a belt inside the solar system. If today all the asteroids merged into one planet, we'd get a cosmic body that would weigh only 4% of the mass of the Moon. Previously, the belt was densely populated, but Jupiter's gravity threw 99% of the asteroids to other places in space. Jupiter isn't the only one that plays a role in the development of life on Earth. Our main assistant is the Moon. It's the only natural satellite of the Earth. Jupiter has 79 satellites, and every year there are more and more of them. Jupiter is also surrounded by rings, but they aren't as beautiful as Saturn's and are practically invisible. The rings are composed of small black particles. This is the dust that the meteorites eject into space after colliding with the moons of Jupiter. The Moon is responsible for the ebb and flow of the ocean. It regulates the life of bees, fish, birds, and amphibians. Even you feel the influence of the Moon every day. Changing the brightness of the disk in the night sky regulates the level of melatonin in your brain. This hormone is responsible for circadian rhythms, which are important for healthy sleep. The Moon came about thanks to another catastrophe, like many other things in space. Millions of years ago, the Earth looked like a ball of hot lava. There was no water or air. It was enveloped only in carbon dioxide and nitrogen. At this time, another planet the size of modern Mars crashed into the Earth. Scientists named it Theia. At a speed of 8,900 miles per hour, it collided with the Earth. The impact of incredible force threw millions of tons of material into space. The debris gathered into a ball that became known as the Moon. Scientists have almost solved the mystery of the Moon, but they don't know if there's a solid core in the middle of Jupiter or if it's dense hot soup that hangs in space. Jupiter has the largest ocean in the solar system. It's made of liquid hydrogen, not water. If Jupiter were 80 times more massive, it would turn into a bright star. Jupiter is a unique place that will never be home to humans. The pressure inside the planet is 2 million times greater than on the surface of the Earth. Extreme pressure and temperature would ruin any spacecraft that's gone too far. I guess that means Jupiter would have a crush on you.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP-40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways, in binary star systems and when there's a single star. Binary stars are 2 stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP-40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP-40-365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually, stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star. But there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the Sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the Sun. That's why if you were standing on its surface at its closest approach to our star, the Sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it actually becomes smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. DGSAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DGSAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the moon's south pole are likely to be the frostiest place in the whole solar system. The craters' floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rise Sylvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long. But the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. Dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/1000th of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They're the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. And a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile-wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.
A team of intrepid scientists have devised an audacious plan to unravel the mysteries of the universe. Their secret weapon? Computation. The very heartbeat of living systems. But what's that? And how will computational zones help us to find extraterrestrial life? Let's find out. In our universe, there are special places called habitable zones. They hold the key to life as we know it. You see, planets are a bit like picky eaters. They have specific preferences for their conditions. Just as we humans need things to survive, planets need their environments to be just right for life to thrive. So, what's the secret recipe for a habitable zone, you ask? It's all about finding that sweet spot where liquid water can exist. Water, as we know, is the magical elixir of life. Planets love to have it flowing or sloshing around on their surfaces. So, we need to find the perfect balance. If a planet is too close to its star, things get toasty, and water evaporates into a sizzling mist. On the flip side, if a planet is too far away, it becomes an icy wasteland, freezing water solid and turning potential life into popsicles. But within that perfect middle zone, also called the Goldilocks zone, temperatures are just right. That means planets have the perfect conditions for life to potentially take root. For a long time, scientists have been looking for planets in these zones. And as of January 2023, we have found a total of 63 potentially habitable exoplanets. However, a recent study has changed our view of where we should look for life. Gone are the days of restricting our search to mere habitable zones. Oh no, we're thinking big. Get ready for the computational zones. These enchanting realms could house life forms we've never even dreamed of encountering before. But what exactly are these computational zones? Well, let's see. When scientists search for life in the universe, they usually look for things similar to what we have here on Earth. They imagine creatures living on a planet's surface at just the right distance from their star and using water for important chemical reactions. But what if life can be much more diverse and fascinating than that? Imagine life using different liquids instead of water. Picture life hiding deep underground in icy moons. It's even possible that life doesn't need a star at all. And there might be biological systems that are different from our idea of life in general, but still alive in their own unique way. That's why two clever researchers have come up with a new idea. They want to change how we think about the places where life could exist. Instead of focusing on habitable zones, they suggest looking for computational zones. Think of these computational zones as special kitchens, where the secret recipe for life is being prepared. To make this recipe work, we need three key things. First, we need a variety of special ingredients, like different chemicals. Just like a chef needs various spices and flavors to create a delicious dish, life needs different chemicals for its calculations. Second, we need a source of energy, like sunlight or heat from hydrothermal vents. This energy powers the cooking process, just like heat powers a chef's stove. Lastly, we need a dedicated space, like a kitchen counter, where all the calculations can happen. It's the place where the ingredients come together and amazing things start to occur. In our case, it was our solar system and our planet Earth. Basically, computational zones should have three things: some chemicals, source of energy, and space. This makes a pretty wide sample, isn't it? By focusing on computational zones, the researchers believe we have a better chance of finding signs of life. These zones could lead us to amazing discoveries and show us that life in the universe is much more creative and diverse than we ever imagined. And here's the real mind-boggler. This idea also leads us to think about technology. Yes, AI and stuff. Just as we humans create and use technology, could life itself create its own technological marvels? Life could be biological, digital, or even something completely different. Computational zones give us a fresh way of thinking outside the box and get creative. Now here's another twist in all this research. Turns out that life might be much closer than we think, as if in our own solar system. It turns out that the insides of icy moons, like Europa or Enceladus, answer to all these conditions. They're just as fascinating as the surface of rocky planets. It's like realizing that hidden treasure lies right beneath our feet. Europa is Jupiter's icy moon, which is as old as our Earth. It looks like a half sphere with a bright icy appearance, an off-white color with a hint of blue. Mysterious dark lines stretch across the moon, forming patterns. It lacks towering mountains or deep basins, but instead showcases dark ridges, grooves, and long streaks. As you move toward the bottom of the image, Europa fades into darkness, leaving us curious about what lies beyond. But the most important thing about Europa is that it's a fascinating candidate for life. First of all, this moon has liquid water in abundance. Scientists believe that there might be an entire salty ocean beneath its icy surface. There might be twice as much water as all the oceans on Earth combined, but life needs more than just water to exist. It requires certain chemical elements like carbon, hydrogen, oxygen, and so on. They're like the building blocks of life. These elements are found throughout the universe and make up a whopping 98% of living matter on Earth. And Europa is believed to have a lot of all these elements too. Perhaps they were brought there in the distant past after a collision with asteroids and comets. Although it's pretty cool that we found organic molecules on Europa, it doesn't automatically mean they are linked to life. These molecules can be created in non-living processes as well, but they still give us some very important clues. And finally, energy. It's like fuel for life. Just like we need food to keep going, all living things need energy to survive. On Earth, plants get their energy from the sun through a cool process called photosynthesis. Plants turn sunlight into food, and when animals eat those plants, they get energy too. But the kind of life that might live on Europa can't rely on sunlight. Europa is covered in a thick layer of ice, so there's no sunshine reaching its surface. Instead, life on Europa would have to find another way to get energy. And that way is through chemical reactions. Europa's surface gets showered by radiation from Jupiter, which is not so great for living things up there, to say the least. However, this radiation can actually be helpful. It helps to create oxygen and hydrogen in Europa's atmosphere. But that's not all. As Europa orbits around Jupiter, it gets flexed and squeezed by the planet's gravity. This flexing generates heat, just like how bending a paperclip can make it warm. The heat from this process can provide energy for life too. So as you can see, Europa's potential life forms have to get creative. But this little moon still has a very high chance of supporting life. It's a fascinating and mysterious world out there. And Saturn's moon Enceladus is also an exciting place where life could thrive. But detecting this life is no easy task. The moon is covered by a thick ice shell with a super deep ocean beneath. Even here on Earth, that would be a huge challenge, let alone on a moon halfway across the solar system. Enceladus is nothing like Earth, so don't expect to find cows and butterflies there. But it would have its own unique ecosystem. Some organisms that rely on chemical reactions for energy. Although life on Enceladus, if it exists, might be extremely scarce. But regardless, we should keep exploring it. Any findings would be helpful for our future missions. All these new discoveries open new possibilities and fuel our curiosity about life beyond our planet. Who knows what exciting discoveries await us in the vast universe? Let's keep exploring and find out.